Hi, this is Margo. This is Sunday evening, July the 3rd, 2022. I hope everyone is safe and doing as well as possible. I'd like to welcome everyone to the show tonight. This will be my weekly update that I'll be putting on YouTube. We're going to go over climate-related items for the week, and methane and sea ice and some earthquakes. But I want to start off with an article. I know last week I talked about the fires in Siberia. Well, I want to show the fires in Alaska because it's affecting the sea ice over the Beaufort. It's affecting the Beaufort Sea. So here's an article from Wildfire Today. This was just a couple of days ago, July the 1st, out of Alaska. And the title says, with near record-setting wildfire activity, Alaska moves to preparedness level 5. And it says the weekend temperatures in the state could be 20 degrees above average. Here's the black line for this year. See how they just spiked up already with the wildfires. And says with near record-setting wildfire activity early in Alaska's fire season and a looming heat wave on Thursday, the Alaska Interagency Coordination Center moved to Wildland Fire Planning Level 5, the highest level. Currently, there are multiple large fires that require incident management teams in several areas simultaneously. PL5 status means most of the initial and extended attack firefighting resources are committed to new and existing fires. Nationally, the PL is 2, according to the National Interagency Coordination Center, but each geographic area establishes its own based on local conditions. So, here's Alaska, and you can see all these red dots with the fires, and some are areas where several fires are kind of merging together. There are currently 160 fires in Alaska, and 17 are staffed. With the predicted hot, dry weather, lightning, and red flag warnings, the fire risk is very high. In addition, fire smoke is at health advisory levels in parts of the state. I don't doubt that. And more than 1,646,895 acres have burned so far this season. Since mid-June, the cumulative acres burned to date has been hovering at record levels or above. As of June 29, the only year with more records burned to date was 2015. The average total burned each year in Alaska from 1992 through 2021 was 1,192,909 acres. Here's their forecast for Friday through Monday. And remember, this is 4th of July weekend, so that means fireworks and celebrations and stuff like that, which puts it at high fire risk as well. Friday through Monday, widespread 80s, daily record highs challenged, very high fire risk, reduced visibility and air quality due to smoke. And see, it's over the whole top half of the state 10 to 20 degrees above normal. Here's Fairbanks in the middle of that, and it extends over into Canada as well. Forecasters say a heat dome will settle over Alaska Friday through Monday that will challenge daily record high temperatures. Fairbanks is expected to hit an abnormally high 85 on Friday. That would be 3 degrees below the July 1st temperature record of 88, which was set just last year. So, it says the abnormal heat will pile on to already abnormally dry vegetation, or is known to firefighters fuels. In Anchorage, just 7% of the city's normal June rainfall fell, while Fairbanks saw 36% of its typical June rainfall totals. That's it. So I'll leave a link below with this article. So that gives us context into when we look at the sea ice. I'll just give you a sneak peek here. Here's the Arctic. Here's Alaska. I have the fires layer turned on. Here are the fires, also fires in Canada there. And this gray is all smoke from the fires, and it's been drifting over the Beaufort Sea all week, and that's very bad for the sea ice because you've got soot and ash and sulfuric acid and different stuff falling down over the ice, and well, in the air it's acidic, and so if it rains, then that's so like acidic coming down on the ice as well. So it's very bad for the ice, and that's what we're looking at today. We see this whole Beaufort Sea region is covered in smoke, and it's just hard to see anything over this area because you're looking through smoke. That's a cloud of smoke over the whole region. Let's see. There's the smoke. You see it coming up. And that's all smoke over Alaska. And here it's coming over into Canada too. So, a lot of areas are drier than normal in the west. In the U.S. here, it's like 1,000-year drought, worse than it's been in 1,000 years or 1,200 or something like that. So it's very dire, and this is what we're dealing with as we're heading into the total collapse of our worldwide systems. So let's start off with Climate Reanalyzer. Here we're on the 2-meter temperature, maximum temperatures today. You can see all these greens over the Arctic. All of this is above freezing. And this dark green, we can see that's about 5 to 8 degrees Celsius. And when it moves into the lighter green out here, that's like 10 degrees Celsius. Where you see the white areas, that's above that's around 100 degrees or higher. See, coming up from Texas up into, looks like South Dakota there. And we've got high temperatures over here in Arizona, California, and in the south as well. And here on the other side of the planet, from Africa over, it's like a constant with these really high temperatures in these areas. We've even got a little hint of white here in northern China where it connects up with Russia. Here's 2-meter temperature anomaly, and so we're seeing Alaska in the brown, and that's about 8 to 10 degrees higher than normal. So they're predicting 10 to 20 degrees higher than normal. So we're not seeing that here today on Climate Reanalyzer unless you know, it's a different measuring or something, I don't know. And we're seeing really high, higher than normal here in this Norwegian, Scandinavian area moving into Russia. This area has been releasing very high methane levels this week. It's just been billowing in the highest readings. And we see the brown coming up on this eastern side, mainly where there's no sea ice. Here's the flat view, and then we've got blues, which is colder than normal, right next to the browns. That's from the Arctic air that's come down because of the loopy jet stream, if you want to call it that. Worldwide, we're only up 0.1 C higher than normal. Northern Hemisphere is up 0.6 C. The Arctic is up 0.9 C. The Antarctic is down 3.2 C. Southern Hemisphere is down 0.3 C. And the tropics are up 0.2 C higher than normal. Here's precipitation and clouds, and the green is rain, and we're seeing rain in this North Atlantic from Iceland up. Also up here next to between Svalbard, Novaya Zemlya and Franz Josef Land, we've got rain, and we've got patches of rain over this East Siberian Sea and here over the Beaufort Sea. There's that. Here's what used to be the jet stream. See these big loops? That's the air swooping down. And just, that's the cold air swooping down. Now we've got warm air over Alaska, so anyway, see these big loops? It looks worse every day. And look at the southern hemisphere. This looks like a chain link fence or something. There's no rhyme or reason. Here's sea ice and snow cover, and we'll look at this in more detail when we move to the sea ice section. But you can see a difference with, it's not solid white. You got some changes in the color, and it's mainly extent is what we're seeing here. They don't really reflect the change that much of the thickness or the concentration here. Here's sea surface temperature anomaly, and this is a really important one. This is as of yesterday, and we can see where the ice is melted. See, this Arctic Ocean is warming up really fast, and here in the Kara Sea it's already moving into reds and browns, and that's like 3 to 4 C higher than normal, and around Novaya Zemlya, and this whole Barents Sea, that's all moving into the browns now. And the North Atlantic, look at this Baffin Bay, here's some browns popping up. Here in the Hudson Bay we've got browns, and in this Baltic Sea we're moving into reds and pinks, so that's 4 to 6 C higher than normal. And look here around Kamchatka, they've got reds and pinks, and around Alaska they've got browns. Here off this coast of North America we've got browns, reds, and pinks. Gulf of Mexico is all in the brown now, along with Gulf of California, and then on the other side of Baja, that's brown as well. Here's the flat view, here's the Mediterranean. It's just really saturated with reds and browns from about Greece over west. Then the east side is moving into browns. The Black Sea is moving into browns. This India Ocean is moving into mainly browns. This whole area around Alaska, sorry, I'm kind of brain dead today. Australia is in the browns. Look at this, it's all brown around all of these areas. Look at around Japan, reds and browns, and the Pacific coming across, that's all browns and dark browns up north, and in the southern hemisphere it's browns coming across. Then we have this patch of blue at the equatorial Pacific, so that's colder than normal, and a little bit of blue off the coast of Africa here. Worldwide, we're up 0.4 C, higher than normal, along with the North Atlantic. The Northern Hemisphere is up 0.6 C. The North Pacific is the winner, being up 0.7 C. Southern Hemisphere is up 0.2 C, and the Equatorial Pacific is down 0.2 C, lower than normal. So there's that. Now we'll move on to methane. I have 2 days worth of methane data to go over on NOAA, and then so we'll do Friday and Saturday from NOAA, and then Saturday on CAMS. And I do daily tracking and reporting on my Subscribe page, and if you're interested, we'd love to have you join us over there. It's only $5 a month. If you'd like to support my work and get daily updates on all this stuff, you can do it right over there. And I do a midweek update on usually Wednesdays, sometimes Thursdays, usually Wednesdays. That's similar to what I do on Sundays. Do that over there as well. So here we're on Friday the 1st in the morning on the Met-Op-B or Met-Op-1 satellite. We're tracking the 469 millibar reading, which is about halfway up in the atmosphere. The mean or average was 1927 parts per billion. The high reading was 2330, and notice how far south these pinks are coming in all the way down to the coastline of the Antarctic. And this pink, that's a range between 2000 and whatever is the high number here. 2000, in this case 2330 parts per billion. In the afternoon, the mean was 1928, so that's even higher. The high reading was 2407. See all these pinks across the northern hemisphere too. And for Saturday the 2nd, back to the morning, look at all this missing data on this west side of the U.S. So even with the missing data, where the mean is at 1927, the high reading was 2460, and in the afternoon the mean was 1928, the high reading was 2344, and again a lot of missing data, all of Mexico and the middle part of the U.S. and up into Canada. So a lot of areas with that are high methane areas, it's missing data there. Even with that, we're at 1928 there. Here's the spreadsheet and chart. So the 2nd averages out to be 1927.5 parts per billion. That gives us an overall increase this week of 1.5. So that's 2 weeks in a row we've gone up 1.5. You can see the line going up here, the blue line. And we're kind of getting a slow start on the rising this year. Everything's kind of off behind for about a month, it seems like. But I expect it to really be taking off now. But it is on the general upswing there. We're 15 parts per billion higher than we were this time a year ago, and we're 58 parts per billion higher than when I started tracking this at the beginning of this chart, March the 1st of 2019. Where it was around 1870 parts per billion. So we can see that every year it goes up higher than the year before. So here are the peaks, and then when it goes down, it doesn't go down as low as the year before, so it's on an exponential rise there. Let's see what methane did this week. Here we were in their show last Sunday. So on June 25th, which was Saturday, we were at 1926. Sunday, it went down 1. Monday, no change. Tuesday, it went up half a part per billion. Wednesday, it shot up 2 parts per billion. Thursday, it went up 1 part per billion. And so on Thursday, we were at 1928.5, and we were at that point 2.5 higher for the week and 20 parts per billion higher than a year ago. Then on Friday it went down 1 part per billion, and Saturday no change, giving us an overall increase for the week of 1.5 and being 15 parts per billion higher than a year ago. Now we'll move on to CAMS. This is Copernicus Atmosphere Monitoring Services. They're out of the EU. And I have Saturday the 2nd pulled up, Arctic view, and surface level. And these two websites, the NOAA website and the CAMS website, I track daily on methane and report on it. Here's our color ledger at the bottom. And so the data is for Saturday, and forecast period is Sunday through Wednesday. Look at this. From Norway over to Russia. It's awful. See how it's streaming out? Watch it move out there. Look at the interior heating up here in the forecast period. Here's Komsomolets. It's billowing again, and the North Kara Sea. We've got methane popping off at Iceland on this southern end. We also have our problem spot here in the North Atlantic off the coast of Canada. It's bubbling up again. You can see it right there. Look at these waves move across. That's a sign of very high methane release. Here's the interior of Alaska that's really high. So remember the wildfires that we just looked at. So the fires are increasing the methane release. One byproduct of wildfires is methane, but besides that, the permafrost is thawing out with the fires, and that releases a lot of methane as well. And we can see these light greens and then the yellows streaming across. So this is methane coming up through the sea ice in the Arctic. Or if it's along the coastline, it's coming up without the sea ice, just coming up. And the water's heating up, the sediment is heating up, and then the clathrates, the frozen clathrates that have been stored down there in the sediments are melting, and so the methane is bubbling up. Look at Canada. It's really coming back, filling back up with methane coming across. So we're in high melt now in the Arctic, and also methane will be on the rise. It'll do a little bit of stair-stepping of, higher and then lower, maybe for a day or two, but we'll be on a general uptrend through probably sometime in October. That's generally when we peak out, usually in October. And that's because the northern hemisphere has been heating up with the summer, and then it takes time for things to cool back down as you go into the fall. It takes couple of months for everything to cool down. Here's the North Pole view. Here we can see the whole northern hemisphere, and here's the UK and Germany. Those are pretty blobby. And then moving on down into France, and then this Persian Gulf, that's a high methane producing area because of all the oil refineries and oil stuff going on all around this Persian Gulf. Here's India, China, and here's Japan. And then here in the US, see the big blobs. See this from the upper Midwest over. Mexico. Now we'll pop down to the Antarctic. This has been interesting to watch. We can see the main background color, see, has gone up. It's 1840 parts per billion, and then we're seeing it even higher than that, streaming. It's really continuously coming up around this western peninsula. That's into the 1860-1880 region. You see the difference there. And here around the Brunt Ice Shelf, and at the Amory Ice Shelf, and here in southern part. But it's moving across, it's streaming down. So, see, streaming down from these continents that are around there, land masses around there, like Africa, Australia, New Zealand. Also from South America here. See the streaming down. But it's also coming up independently in over the interior and around the coastline still. And remember, it's in total darkness down here right now. It's their winter time in the southern hemisphere. Now we'll go to the global view. See, you can see the lighter colors where it's streaming down. Here's Australia. See, that's really percolating, especially on that eastern edge. New Zealand. So we're seeing higher readings creep further south into the southern hemisphere. I wonder if our background color is going to move up to 1860. I don't know. Look at the green streaming off of Africa here. Now we'll look at 500 HPA. Look at this. So these dark areas have kind of dispersed. See, they've spread out. Here's a dark reading. This is Russia. And that's just north of Mongolia, it looks like. And here, China, east side of China and Korea, and then across India here and southern Asia. We also have heavy coming across Canada there. And look at Norway. Now watch this when we go to total column. Now we've got a heavy region, see, at the Persian Gulf. Normally it's not this heavy, but this is, you know, where the methane, they add up all the methane through all the layers of the atmosphere and come up with total column. So that's where it's heaviest, most heavily concentrated. And so there it is at Persian Gulf, India, coming over into China, and then this east side of China. And then red, the reds are the next color down. So there's that. Now, we'll just show a couple more. This is from CAMS. This is the smoke from the wildfires. We're looking at the Arctic view. Here's Greenland, here's Canada, here's Alaska. Now here's the smoke from Russia, so that's minimal coming up from Russia compared to what's coming up from Alaska. And you can see how it's so we've got fires toward the southern end, and then it comes up through the middle of the state, and then the smoke comes all the way up over the ocean there and spreads out, and then it's spreading out over Canada because there are fires, some fires there too. Here's sulfur dioxide, and we can see the higher reading up into the golden color here in Alaska. Now this is at 500 HPA, and usually with wildfire smoke, that's at, that stays closer to the ground. It doesn't usually gather too densely at 500 HPA. We do have a high reading down here next to New Zealand. Now let's look at this. Here's the Pacific view. So here's New Zealand. So it's just off the coast, just northeast off the coast here. That's a new sulfur dioxide reading. It looks pretty blobby. I don't know if this is volcano related or earthquake related. I just don't know. But you can see it shot up at 500 HPA, and so that's could be either. And see, we've got, this is kind of a constant from Popocatépetl volcano in Mexico, and you can kind of compare what's coming up here. So this is, you know, a few times larger than that. So I just don't know about that. Here's the Antarctic with the ozone. We can see the greens are spreading out over the interior, and we got these breaks coming up. And here's the Arctic with the ozone, and we're getting more greens appearing here, so it's thinning out. Methane will cause the ozone to become thin. If you have high methane release over a long enough period of time, it makes holes in the ozone layer. We've got a little bit of green here coming up across Canada. Also in the western part of the US, we've got greenish right there. Here's the global view. We've got an aqua band opening up across Indonesia and northern Australia. So that's letting through more radiation. So you need to be really careful if you're outside. Don't try and get a tan. More incidences of skin cancer, severe burns, things like that, when you start getting these really thinner readings. Also, it'll affect the crops, burn the crops, and, you know, dry out the soil faster, things like that. And see these greens moving up through India, Africa, and see this greenish through a lot of the US there. That's all of those. Now we'll move on to the sea ice portion of the show. Okay, we're going to start, I think I'm going to start with the images from Climate Reanalyzer. I download these and save them every day. So here's the sea ice and snow cover for today. And if we zoom in, you can see where it's really like super thin here in the Hudson Bay and around. I think this is a little bit different from the other models that we'll look at, but anyway, this is what they're giving us. I know there's not this much sea ice in the Kara Sea right now. So, kind of have to take it with a grain of salt. So this is why we look at several different models for the ice. So let's see what it did this week according to them. Here it was last Sunday. It looks about the same, doesn't it? So we'll just click through. Here was Monday, Tuesday, Wednesday. It's like almost no change. Look at this big change here on Thursday. See this just really diminishing here in the Beaufort Sea. That was from the wildfire smoke coming up from Alaska. And see the diminished ice here in the Hudson Bay and the Baffin Bay. I think this is more realistic to how it really is. And see, Nova Zembla, almost ice-free there. And then look at Friday. Kind of all comes back magically, and so I don't think that's accurate. I really don't. And then Saturday. So whatever they're doing with their modeling, I don't know. That just doesn't look right to me for it to be you go from this on Thursday, and you'll see when we look at the Navy models and then NASA Worldview, this is a lot different. But again, you can't really tell thickness here. It's mainly extent, but it looks like it magically grew back, so I think that's just wrong, frankly. I just don't think that's, I mean, there's hardly any ice over here in the Kara Sea when you look at the satellite view. So anyway, just thought I'd show that. Now we'll go on. Next we'll look at the Navy models, U.S. Navy. This is the Arctic sea ice thickness. Here's our color ledger on the right, going backwards in the rainbow from white is nothing, and then up up to reds, and we just got a little sliver of the dark red, which is 5 meters thick. Let me zoom in. And how much it's already melted is really astonishing. And typically what we'll see is from about the summer solstice on to about the first part of August, it melts really, really fast, and then it starts slowing down. And I mean, it continues to melt, but then it starts slowing down until it reaches its minimum, usually around mid-September. And it slows down because the North Pole is starting to tip away from the sun, and so it's not getting those direct rays. The further it tips away, then it starts slowing down with the melting of the ice. So it's still in, it's getting the brunt force. It's a very high melt right now. So here we are today. See, according to this model, this Kara Sea is almost ice-free, just a little bit next to Nova Zembla, and here in the North Kara Sea, a little bit left. This eastern edge is diminishing, and also down along Greenland, you can see that's in high melt. And here in the Laptev Sea, see this is in high melt, and see how it's thinned out in this big circle coming out towards the North Pole. And this area, see, it's into dark blue and dark purple. That's about 1 meter thick to 1.25 meters thick, this whole area. And then it shifts over into the aqua, the dark aqua. That's about 1.5 meters thick. And then the bright aqua is about 2 to 2.5 meters thick. There's just a line north of Canada and Alaska. I mean, not Alaska, Canada and Greenland. That's really that bright aqua. So not much of that. And then the green is about 3 meters thick, and it's just mainly right above Canada here, then a little bit above Greenland. and then the bright red is about 4.5 meters, and then the dark red is 5 meters about, and just a hint of yellow, and that's about 3.75 meters thick. So not much of the thicker ice. It's right along here. And these tributaries, you can see those are really starting to melt. The ice is starting to flow out. This nearest strait, that's this little channel between Greenland and Ellesmere Island. That's the ice is flowing out through there. It's also exiting here in the Fram Strait. In you can see here along the Canadian coastline and going down. That's melting out. That's an exit point for the ice. Also, see where it comes in around these islands and this archipelago. These are all exit points for the sea ice. And as these melt, this ice is just going to be flowing out. And here you can see how it's really thinned down in the Beaufort Sea, down into the purple, even moving into lighter purple, so even less than a meter thick. We got a little bit thicker ice as you come up to the Alaska and Canada coastlines, but in the center of the Beaufort Sea, that's really melting out, and we're seeing quite a bit more open water there. And of course you have to visualize that smoke that's come up from Alaska and Canada, and so where the smoke is, that's where it's really thinning out. We also had some rain over this area this week. That didn't help matters any. And then we've got dark aqua coming across to Russia, and then around New Siberian Islands, that's pretty much all melted out. And both the Bering Strait, that's open, and it's melting up further in at the Chukchi Sea. Here, the Sea of Okhotsk, that's clear. The coast of Alaska is clear on this west and southern edges. Just a little bit around the coast here where it meets up with Canada. And here at the North Pole, see, that's not where the thickest ice is. The thickest is just a little bit south of the North Pole. So let's move on. Oh, and then here in the Baffin Bay, that's in high melt, and Hudson Bay, that's in high melt. So let's look at the 30-day animation. This was updated to yesterday, so the data goes back 3 weeks, and forecast period goes out to next Saturday. So you're going to see really thinning down. It's really shocking to see the change just in the final 2 weeks of the model. So so I'm going to stop it. Here we are at the end of the model on the 9th. So here's what it's showing. Mainly almost no ice here in the Hudson Bay, thinning way down here in the Baffin Bay, still thinning around Greenland. These the extent is still coming in slowly, but it's mainly this thinning in the interior. See how this aqua portion has moved down, and here in the Beaufort Sea it's moving down into light lavender, so that's a lot of open water when you start seeing that. A lot of holes and open water. And still have some thicker ice here next to Siberia. So we could see as we move further into July, we'll be seeing we'll be seeing open water all the way down, probably past the North Pole. This is going to keep whittling down and getting smaller and thinner as the summer progresses. So let's go back. Here we are today. I think, yeah, there we are today, and I'll just click through slowly and you can see the change from day to day. It's dramatic. Look at this. Let's see. Big changes. And there we are for next Saturday. So as things open up, we'll have the thickest ice left right above Greenland and Canada, this area, and then if these tributaries melt out, it could all just flow out, just in a very short amount of time. And they did not update their Beaufort Sea Ice model since the 28th, so we're not going to look at that tonight. Now we'll move to the Antarctic, and here we're looking for refreeze, and here we're looking for ice around the continent, and here's the Weddell Sea, and here's where most of the thickest ice is, just parallel to this western peninsula, and the extent is still slowly coming out, little fringe, and it's still thickening here in the Ross Sea. So let's run this 30-day animation. Again, this was updated to yesterday, so the forecast goes out to next Saturday. So we see it slowly inching out. And typically this ice around the Antarctic doesn't get real thick. And in their summertime, most of it melts and then it has to refreeze during the winter time. And so what we look for also is the glaciers you know, if they start calving, then, you know, they can start flowing out in the ocean. And then when the glaciers start going, that raises sea level around the planet. So there's that. Now this is the National Snow and Ice Data Center model. This is as of yesterday, July 2nd. This is the Arctic sea ice concentration. Wherever you see the blues, that's where it's melting. And the darker blue it is, that's where it's already melted out the most. So we can see this Beaufort Sea is really taking a beating. This whole west side, see? And so this doesn't really match up with the Navy model, with the melt that we're seeing coming further down. But they're all different. They each have their own modalities. But this does match the Navy model with the Kara Sea, with it mainly being open. See, except for a wisp beside Novaya Zemlya. And here's the chart for the Arctic sea ice extent. Now they count every little wisp, even if it's just a little skim, they count that as extent. This blue line is this year, the dotted line is 2012, and the gray line up here is the median, and we're still headed down. We're kind of running parallel with this gray line with the melt, and we're still just a little above 2012. And here's the Antarctic. The gold line is the median, so we're still pretty far underneath that on that north end. Here's the extent. The blue line is this year, this green line is last year, the gray line is the median, and it is heading back up at a better angle here, running parallel to the green line, but we're still well below last year and the median. Now switching gears and taking a look at Greenland. For the last few days, Greenland is in very high melt, and this is not looking good. This is yesterday's melt. All this salmon, see the dark salmon. All the edges, almost all the edges are melting, and look at the wide area on this whole west side of the ice sheet. That's very bad. Look up here, and here's the cumulative melt days so far this year, and you can see it's inching in onto the ice sheet. Here's the extent so far, and so it's been going up this week. I've been posting and tracking this. See how it jumped up a couple of days ago. Now, right now, it's at about 20% melt. Day before yesterday, it was a little higher than that, about 21% melt. But see, it's higher than median there. So that's not good. So that's all of those. Now we'll move on to NASA Worldview. Before we go there, I want to briefly show oh, didn't mean to go there. Well, while we're here, look at all the fires. Here's the Congo, Africa, here's South America, here's Russia, and so on. So we have fires all around the planet all the time. Now here's Alaska and Canada. So when you see them up north, I immediately think of the thawing permafrost, and that, you know, it does double damage. Alright, let's go to the Antarctic. See, all this is in the dark. And we'll turn on our nighttime layer. Where am I? Here we are. Here's this Western Peninsula. We'll zoom in, and I'm tracking this iceberg A76, and we're seeing if it's going to get frozen in. Now there's ice out here. I'm thinking it's going to get icebound during the winter. Here's this tippy point of this Western Peninsula, so it's moved out past that, and here's ice on, it's icebound kind of on the right, but it's open here on the left, and it's pretty much straight up and down. So it's still trying to move out. Here we were last Sunday. Here it was, just barely making it out. And here's Monday, Tuesday. Tuesday they were having problems with getting data. Wednesday, and here we see open water on the right, so it shifted over to the left there. Here's Thursday. Can't really see it, there's a cloud there. Here's Friday. See the open water where it shifted back. Now this right side is next to the ice. Here's Saturday, so it moved a little there, and here it is today. So we still have open water on this left hand side, but then there's ice out here that's already refreezing. So I'm thinking it's going to get caught up. So we're just tracking it. That's my big hobby, is tracking all this ice and stuff. Now we'll go to the Arctic. I'm going to turn off the fires. We already saw that. I'm going to turn on this is sea ice in concentration for today, and we're going to turn on the blue marble view. That takes away the clouds so we can see better. And wherever you see the colors, that's where it's melting. When it gets down into green or blues or purples, that's open water. There are holes, and so that's ice on its way out. So let's go back. let's go back to last Sunday, 26th. Here we were last Sunday, and it was in high melt here on last Sunday at the Beaufort Sea. So let's see what happened this week. Here's Monday. Look at that. Tuesday. See how it's moving down. How it's shifting. Wednesday. Thursday. Here's Friday. Saturday. And then here's today. Now this ice, depending on the ice drift, the ice is just sloshing around, and so you'll have holes that open up and then they close up when it moves back. So that's why you see so much change there from one day to the next. So that's what we've got. Now we'll turn our clouds back on, turn that layer off, and let's go in and just look at the satellite view. So we started down here in Alaska with all this smoke. See? It's just awful. That air quality has got to be terrible. And it's hard to really make out the ice. Now here's some ice here. Here's some ice. But there's quite a bit of open water. See, you can make out through the smoke where the ice is just really poor. And see here where it's coming apart. Here's a hole. Look at this. So it's melting in between the pieces of ice, and then as it becomes more open around the pieces, of course that's absorbing radiation from the sun and heat, and so that's all this water is heating up, and then these pieces of ice they'll slosh around, and it's also heating from underneath, from the water coming in from the Pacific and everything, and on the other side from the Atlantic. And so then these ice pieces or ice cubes just start melting faster and faster. So once you get going, it can really go fast. See, look at this. So this is one of the exit points for the ice. Let's look here. Look at this. See where you see it changing into that blue-green. It's thinning down. See the lines. Those are the leads, and they're getting ready to break apart. Those are the cracks. See, like this area. So this is really thinning down. So, so this is the archipelago from Canada, and you can see this blue-green all the way through. So this is all thinning super fast, and really more early in the season than normal. And here, see, this is Ellesmere Island, and see, that's melting inside there. Here's the Lincoln Sea. Here's the ice up here. And here's a cloud. Here's Greenland. This is the nearest strait. It's pretty much cloud covered right now. Let's go back. Yesterday. Kind of hard to see anything. So here it was Friday. Let's see, where it's opening out into the Baffin Bay. See, that's open. See the wispy ice. They count all of this. Every little crumb. They count all of this for extent. Because any little bit of ice can reflect the sunlight, even as it's in high melt. And that's its job. It's supposed to reflect the sun to keep things cool. Here we are today, so we've got a big cloud there. So down here, see, here's the ice sheet where it's this whole western side that's melting. We've seen the salmon color here for a few days now. And you see these, with the runoff. See the runoff here? See where that's melted? And so this will just flow down. And then exit down here. Okay, let's move on. Here's this east side of Greenland. Here's a little wispy ice. See, little fringe hanging on. And here's our rain cloud. Here's Svalbard. See, that's open. Let's see. Pretty cloudy, but you can see that there's no ice around it now. This eastern edge of the ice, kind of hard to make out because the clouds, it's right along here where you see the bright white. Here's Franz Josef Land. See how this ice is melting out. The group of islands there. Here's Novaya Zemlya, and there's just a little bit of ice along the coast there. These are clouds, and then a little bit of ice here. But that's it for this part of the Kara Sea. Here's the Yamal Peninsula. And going north. And there's a little ice underneath those clouds, not much. So you can, like here where it's thinner with the clouds, you can see the ice breaking up here. There's a lot of open water there. Here's Severnaya Zemlya. Right down here is Komsomolets, and right around this island is where methane is billowing again. That we see it on cams. We can't see it here. Here's the Vovolov ice cap. It's ice cap. And it's flowing into the ocean right there. And here's the Taimyr Peninsula. This is open. Look at all this open water. This is open. This is the Laptev Sea. And here's the Russia coastline. And this ice is in high melt. Pretty cloudy. Look, here's yesterday. That's a good view. Look at this. See all the brown. That's sediment. All these rivers that empty out. This is the Lena Delta, where all these rivers come together, and then, or the Lena River comes up and empties out here, and it spreads out into all these little tributaries. See the brown. Here's New Siberian Islands, and a lot of open water here. See, that's breaking up. Here it is today. See the bluish green. That's algae. There's the coastline. See, that's in high melt. Let's move down while we're here. See, as we go further south, see how that's breaking up. See. Let's look here. Look at this. This, okay, you can see the ice here through the clouds. Look at this. That's at 87 north latitude. 90 north latitude is the North Pole, so we're getting really close to the North Pole with this huge breakup. See the cracking there? You can see it here. Look at this. Bunch of open water there. Here. That's at 88. 88.8. 88.83 north latitude right there. And then here's the North Pole. Look at this. These are ice pieces, you can see that. Look at this. Wonder what that is. That's really freaky. Looks like a zipper, doesn't it? All the way down. Look. Oh, they run parallel to these lines. Maybe it's part of the model. I don't know. I haven't noticed that before. Look. That we've got them parallel to all these black lines. That's really weird. I haven't noticed that before. Okay, going back up, here we can see melting ice. And then coming up, see, we've got a bunch of clouds, but you get the idea. See, open water around the ice. And here's Russia, and here's the ice as it comes out towards the Chukchi Sea. See, that's in high melt. And here's the Bering Strait, that's open. Look at these clouds. A lot of it is not really clouds, and I'm not going to talk about it here. It's very, look at that. Look at that. Well, look at this. That was the 29th. So here's a good image of how open this is. The Bering Strait, and coming up around Alaska. Here's Barrow. Let's see, we've got a cloud there. So here we are today with the smoke. So, now, here we are on the 29th, and see the smoke. There's a little bit of smoke coming up here from Canada, but not a lot of smoke coming up into the Arctic on the 29th. See, it's mainly down here over Alaska, but watch this. Here it comes. The 30th was the first day where it was really spreading out over the Beaufort Sea, and that's when that really started melting. Look at the first. And see, here it's spreading out. And here. And here's the second. Look at how smoky that is. And then today. It's just solid over the Beaufort Sea. And I think that's about it. But, you know, see how this is turning that greenish color. That's really thinning. And, watch this. Here's the melting this year. Here in these tributaries, and look at last year. Now, it had already opened up down here, but the colors, oh sorry, I meant to do the year. Look at that. Look at the difference. It's melting a lot more this year right now. See, there's last year. There was the 2020. Here it was 2019. (2018) and so on. So that's gone soon. Now, let's see what's going on with earthquakes. Right now we've got 201 worldwide, and being a holiday weekend, the earthquake makers in the U.S. are home Sunday and Monday at least. A lot of them are off Friday and Saturday too. Meaning the quarry blasters. And we still have, look at this cluster in West Texas, we've got 5 here. 3.0 was the largest. And over here at Eureka, Nevada, it's been rocking for the last 2 or 3 days. 3.5 I think is the largest. So these are 4s, not huge. So if we do 7 days, all magnitudes, let's do that next. 1,930 worldwide. We've got a couple here in the middle of the Atlantic, just west of Spain and Portugal. Then here in the South Atlantic, look at all these. There was a I'm losing my voice. 6.0 in the Philippines. There was also here in the Persian Gulf, in Iran, right next to the Persian Gulf. There were 16 here. See, there were, look at the 6.0 on the first, and then a 5.7 and another 6.0. All of those were on the first, and it's still moving a little bit since then in 4's range. And then that 6.0 was just off the coast of the Philippines. Anyway, we had some movement next to the Juan de Fuca plate. We had one up here in northern Nevada. Occasionally we'll have them up there. 3.2, and it was 70 kilometers north of Black Rock City, Nevada. And Black Rock City, if people don't know, that's where Burning Man takes place. I don't know if they're going to have it this year or not. I haven't heard. Anyway, lots of movement. It's just covered up. Let's look at 7 days, 4.5 magnitude or higher, and see nothing in the U.S. So they were all under 4.5 magnitude, just a lot. So only 75 worldwide. 4.5 magnitude or higher, and it's around everywhere else. So that's my report for tonight, and I always like to bring it back to a spiritual viewpoint, being as we're so close to the end on so many different levels. And you can prep physically for as long as you can, but you really need to prep spiritually and emotionally to be ready to leave. And so we're reading out of the Book of Wisdom, which is one of the books of the Apocrypha, and this was written by King Solomon. Wisdom chapter 8. Wisdom reacheth from one end to another mightily, and sweetly doth she order all things. I loved her and sought her out from my youth. I desired to make her my spouse, and I was a lover of her beauty. In that she is conversant with God, she magnifieth her nobility. Yea, the Lord of all things himself loved her, for she is privy to the mysteries of the knowledge of God, and a lover of his works. If riches be a possession to be desired in this life, what is richer than wisdom that worketh all things? If a prudence work, who of all that are is a more cunning workman than she? And if a man love righteousness, her labors are virtues. For she teacheth temperance and prudence, justice and fortitude, which are such things as men can have nothing more profitable in their life. If a man desire much experience, she knoweth things of old, and conjectureth aright what is to come. She knoweth the subtleties of speeches, and can expound dark sentences. She foreseeth signs and wonders, and the events of seasons and times. Therefore I purposed to take her to me to live with me, knowing that she would be a counselor of good things, and a comfort in cares and grief. For her sake I shall have estimation among the multitude, and honor with the elders, though I be young. I shall be found of a quick conceit in judgment, and shall be admired in the sight of great men. When I hold my tongue, they shall bide my leisure, and when I speak, they shall give good ear unto me. If I talk much, they shall lay their hands upon their mouth. Moreover, by the means of her, I shall obtain immortality, and leave behind me an everlasting memorial to them that come after me. I shall set the people in order, and the nations shall be subject unto me. Horrible tyrants shall be afraid, when they do but hear of me. I shall be found good among the multitude, and valiant in war. After I am come into mine house, I will repose myself with her, for her conversation hath no bitterness, and to live with her hath no sorrow, but mirth and joy. Now when I considered these things in myself, and pondered them in my heart, how that to be allied unto wisdom is immortality, and great pleasure is to have her friendship, and in the works of her hands are infinite riches, and in the exercise of conference with her, prudence, and in talking with her, a good report. I went about seeking how to take her to me. For I was a witty child, and had a good spirit. Yea, rather, being good, I came into a body undefiled. Nevertheless, when I perceived that I could not otherwise obtain her, except God gave her me, and that was a point of wisdom also, to know whose gift she was, I prayed unto the Lord, and besought him, and with my whole heart I said. Wisdom chapter 18. And so we're going to be left hanging in the middle of the sentence with a comma ending this chapter for another week to find out what he said. So goodness and righteousness, these are things we should all strive for, and it will be found less and less as we go forward as in the dark days. And the darker it gets, the brighter the light will be, and it's the light of Jesus. He said, I am the way, the truth, and the life. He also said, I am the light of the world. And he said, the only way to my Father's kingdom is through me. So I highly recommend that you give your life to Jesus Christ and get to know him. It's not too late. It's not too late. So I love you all, and I'm praying for you. Hope you have a good week. And until next time, God bless you. Go in peace, and I will talk to you soon. Good night.